In this video, we're going to look at how blocks get made on Snapchain. So we previously talked about, each app can have their own nodes, and you can see Warpcast and Super here are communicating with their own nodes, and there are many, many other nodes all marked in blue on this chart that represents other apps or other developers in the system. Now, there needs to be some system by which we agree on what the next block or next set of transactions is, and everybody moves forward and accepts that state transition or that set of changes to the network. And typically, if you look at networks like Bitcoin and Ethereum, there's sort of a special class of working nodes. In Bitcoin, they're called miners. In Ethereum, they're called stakers. We call them validators. And these working nodes are the ones that are responsible for producing blocks. Usually, they earn the right to produce blocks. In Bitcoin, it's through mining. In Ethereum, it's through staking. And then a single node gets the right to publish the next block. Everyone accepts it as the truth. And that block gets propagated out to the rest of the network. We have validators, and we actually have about 3 of them. And the first thing you'll notice is that we have a lot fewer validators than other networks. In Bitcoin and Ethereum, you actually want a very, very large set of working nodes because because they guarantee the economic security of the network, and compromising these validators has great financial upside. Like, you can make a lot of money if you're able to take over a validating node and dictate what happens next on the network because of the nature of financial transactions happening there. That doesn't exist on Farcaster. You can't actually make money by slowing down certain transactions or speeding up other ones in the same way. And the second reason is Farcaster also relies on Ethereum for its account security. Ethereum has to guarantee its own account security, but we can sort of guarantee that because accounts are established on Ethereum, because the keys are established on Ethereum, that we are using Ethereum security to guarantee the sort of signature validation part of the network. And then really what Snapchain is doing is providing a quick way to sync all of this data between nodes and ensuring that that sync process is resistant to censorship and a single party can't block someone unilaterally from writing to the network. And so we have this small set of working nodes called validators that are nominated by the system, by the community, to produce blocks. And the reason we have multiple validators is so that they can round robin. So the first validator produces block 1, the second produces block 2, and the third produces block 3. This gives us some amount of protection if one of the validators were to fail, and even protection if one of the validators were to become malicious. So let's say they decided they were going to block Alice's transactions. Let's say validator 1 said, I'm going to block Alice's transactions. Validators 2 and 3 would still accept her transactions and keep putting them into blocks. So the flow of information in the network kind of starts from the clients. Warpcast and Supercast send their messages to their own nodes. These get put into this peer-to-peer mempool that connects all of the nodes and validators together. And then the validators keep reading messages from this mempool, putting them into blocks, and occasionally publishing blocks. And at any given time, one validator has the right to publish the next block and will put out this block. And once a block is published, it also goes back out in a peer-to-peer mechanism to all the other nodes that now accept this as the new state of the network. They sync the block and they move forward. Now, the way we choose validators, we try to choose different entities so that there's some spread of governance in terms of who gets to decide who gets control over what messages get published. And message publishing is also visible to everyone. So you can see that, let's say one of the validators decides to block Alice. You can see that Alice is publishing messages to the mempool and then they just never end up in blocks. And you can see which validator is active at the time when that happens. And so you have sort of this high degree of knowledge of, validator 1 is censoring Alice, and then the community can come together to kick out that validator and replace it with a stronger validator. And as always, every decentralized system has some assumptions of honesty, and the honesty underlying Ethereum and Bitcoin is, at least 51% of nodes are honest. The honest assumptions underlying our system are at least one validator is honest, in which case you will always get your messages through. And if that were to be threatened, we would rely on social consensus or social forking to replace it with a new set of validators. But ideally, if one of the validators gets faulty, the community comes together, detects it, changes the validator set, and then the new validators are more censorship resistant than they were before. And so this is the underlying architecture that guarantees that data flows quickly and freely. So the blocks are produced every few seconds, and they're able to take thousands of messages per second and sync them between these nodes, but also ensures that no individual person can get censored on the network because there are multiple validators run by different parties, and they all would have to collude together. All of them would have to collude in order to block any single user on the network. So this strikes a nice balance between speed and the ability to do thousands of transactions per second, but also not having a single entity or single server that is in charge of deciding which messages get through. We now actually have 3 or more servers that are working in tandem and syncing all these messages out to the rest of the network. And again, as a final reminder, the worst thing that a validator can do is actually just not accept a transaction. It can never fake a transaction because every one of these are signed. It can never spoof something or pretend someone says something they didn't. The only thing that it can do is prevent a transaction from getting into a block that it is able to produce. It can't affect any other blocks. And so blocks are sort of produced one after another sequentially, and we'll talk a little bit more about how all of this works and how the scaling kind of kicks in the next video.